Hi guys, welcome to Math File channel, and in this video we're going to look at an assessment I gave to my 11th graders this week, and we're just going to go through. They were supposed to use 90 minutes for the entire paper. Calculators are allowed in this paper. Let's see how fast you can go through this. There are about 10 questions with one question as an extra question, and yeah, we'll try as much as possible to finish up at least half of it in the first video. This video is not going to take more than 30 minutes. Let's cap it at 30 minutes. So we've got a lot of questions we have to work on, and the test is mainly on calculus, that is differentiation, the first part of the differentiation. Then we've got trigonometry in there, and also I think we've got circular measure. So 3 topics, and they had 90 minutes to work on it, and there's an extra question for extra credits. So let's start with question number 1. Quite interesting question. Yeah, there's a circular measure question. This says that the diagram shows a right angle triangle ABC and a sector CBDC. DC, okay, of a circle with center C and radius 12 centimeters. Angle ACB is equals to 1 radian, and angle ACB is a straight line. So this line is a straight line, which means that angles in a straight line add up to 180 degrees, or we can say that angles in a straight line add up to pi. Okay, you have to line up to get a pi. Okay, show that AB is approximately 10.1 centimeters. Looking at this triangle, let's try to bring out this triangle. Looking at this triangle, I think we can show whatever we need from here, because it's a right angle triangle with this distance also being 12, since that is also a radius. So we can use the secateurs, which we can say that sine 1 radian is equal to opposite, which is AB, over the hypotenuse, which is 12. So straight away AB is equal to 12 sine 1 radian, and let's use a calculator. So 12 sine 1 radian, that is going to give you, wait, my calculator is in, let me change the settings of the calculator. So radian, okay, 10.097. so AB is approximately equal to 10.1, since 10.097 is more or less like 10.1. Yeah. So find the perimeter of the shaded region. We need to first come up with a strategy to find the perimeter. So to get the perimeter of the shaded region, there are some aspects that we need to include in the perimeter. This should be this length AB. Already we found this. We are good to go. And we also would need the length CD, and we would need the arc, this arc, to continue. So the key things will be the formula for length of arc, and also how to factor in the AC over there. Just like we did for the other one, I think we should be able to find AC, and since this is known as 12, we should be able to find AC. Again, we're going to use this time we're going to use cosine. So let's use cosine. So cosine of 1 radian is equal to AC over 12. Let's be sure about it. Yes, cosine of 1 radian is equal to AC over 12. Then AC in this case is going to be 12 cos 1 radian. So 12 cos 1 radian, that should give you 6.48. So AC is equal to 6.48. And we need to get the arc BD. Length of arc is theta r, so I need to get the small theta. Let's call this theta. So I can say that theta plus 1 radian is equal to pi. You have to be in line to get a pi. So theta is equal to pi minus 1 if you make change of subject. So it should be 2.14 approximately, but let's confirm. So pi minus 1 should be 2.141. So let's say 2.142. So 2.142, that is theta. Now we can use this theta to find the length of arc. So length of arc BD is equal to theta r. We know theta to be 2.142 and r to be equal to 12. So we can quickly find this one. So 2.142 times 12, this should give you 25.699. So 25.699. Okay. I think we have everything we need to find that. We've got this one to be 25.699. We've got the length AB to be 10.01. We've got AC. So the perimeter is going to be equal to AC 6.48 plus I think we'll need the length of arc, so 25.699 plus we'll need this 12 centimeters and this 10.1, so 12 centimeters plus 10.1. So this 10.1 is AB and the 12 centimeters was CD. Then the 6.48 will be AC and the length of arc. So adding all this together, that should give you the answer to the question. So this was a pretty straightforward question. I don't think it should be challenging. Plus 12 plus 10.1, and this will be 54.279. So let's say 54.3 to 3 figures centimeters. Okay, so the next one to find is the area of the shaded region. So the area of the shaded region can be really interesting. We need to first find the area of the triangle, this triangle. Then we later find the area of the sector. So we have everything to find the area of the triangle. We've got AB, we've got AC. So area of the triangle, let's do that quickly. So the area of triangle is going to be equal to half the base, which is AC. We got AC to be equal to 6.48. So 6.48 times the height, which is 10.1. Let's get this sorted. So 0.5 times 6.48 times 10.1, my bad, that would be 32.724. Then area of a sector is equal to 1/2 r squared theta, and we've got the r already, so this is basically 1/2 times r squared, which is going to be 12 squared, and the theta we calculated it to be 2.142. So let's do that one to 0.5 multiplying 144 times 2.142, and that gives us 154.224. So 154.224. Then the area of the shaded region, so the area of shaded is going to be 154.224 added to 32.724. So added to 32.724. This gives you 186.948. 186.948. So that's the first answer to the question. So 10 marks for this. Question number 2. In this question, all lengths are in centimeters and all angles are in radians. The diagram shows a sector AOB and COD of two circles with the same center O. The angle AOB is 3 pi over 8 and the length of OC is 6.5. It's given that OAC and OBD are straight lines, and the relationship between OA and OC is that OA to OC is 4:5. You have to find the perimeter of the shaded region. So it's always best to develop a strategy to solve the question. So with this one, the strategy to find the perimeter of the shaded region will be getting this length AC, which is going to be the same as this length BD. Then we can find the length of arc AB. Then we can support that one with the length of arc CD. So that's the strategy we're going to use to solve the question. If not for anything, what we have the length of OC. At least we should know that we won't get 0 on this, because you can use the OC and the length to find the arc length CD. But let's see what we can do. So OA, you can use the small method to go by this one, or you can write this as fraction. So OA over OC is equal to 4 over 5. So OA, do we know OA? We don't know OA. So let's represent it with OA. I wanted to use X, but it's fine. OC is 6.5. This equals to 4 over 5. So let's do the cross multiplication. 6.5 times 4 divided by 5. That should give us 5.2. So OA is 5.2. Okay. So if we know OA is 5.2, we should definitely get what AC would be. So AC would be equal to the bigger one, OC minus OA. So OC was 6.5 minus 5.2. Let's see what we get with this one. So 6.5 minus answer should give us 1.3. So there's 1.3. Let's indicate it on this. So there's 1.3 and there's 1.3. So at least we've gotten 2 parts of what we intended to get. The next thing to do is to find the arc length AB. So length of arc AB, length of arc is r theta. We know the radius, so AB would have the radius of OA, which we calculated OA to be 5.2. So that's 5.2 multiplied by theta, which is 3 pi over 8. So 3 pi over 8, and that becomes the length of arc. So let's use a calculator. So 5.2 multiplied by 3 pi over 8, that should give you 6.126. So 6.126. Then let's find the length of arc of CD. So length of arc of CD. So again, theta r, but with that one, CD would contain OC as a radius. So OC will be the radius, which we're given that to be 6.5. So 6.5 multiplied by 3 pi over 8. So let's just edit this one. There's 6.5, and that should get you 7.657. Oh no, 7.658. So 7.658. So to finish off with everything, we can just add up. So the perimeter, which is going to be equal to 1.3 plus 1.3 plus 6.126 plus 7.658. So let's finish up this. 1.3 plus 1.3 plus 6.126 plus 7.658. So this should give you 16.384. So 16.384. 16.384. Is it 348 or 384? Yeah, 384. So that becomes the perimeter of the shaded region. Now B. The diagram shows a circle with center O and radius A. Sector PQR is a sector of a different circle with center R and radius Y. Angle OPR is phi. Find in terms of A and phi only the total area of the Wow. Find in terms of phi and a only the total area of the three shaded regions and simplify your answer. Okay, so that is quite interesting. Let's try to break this one down. Again, the strategy to solve for this one should be pretty easy. So what we're going to do is to first find the area of this sector. Find the area of the sector, then we subtract this one from the area of the circle. So we find the area of this and we subtract it from the area of the circle. So we now have a strategy built. Let's see how we can solve the question. Looking at this one, I think it would be best to complete certain things over here. We're told that this is a radius, RQ is a radius, and RP is also the radius of a circle. So this is A for the bigger circle. If that's the case, let's put phi over here as well. Now I can also see that the two triangles are congruent by the side principle, because this side is A, that is OQ, OR, and QR, contains side A, and Y. Then O with the triangle OPR, it also contains sides A, and Y, since there's also Y. So by the side principle, we can say that the two triangles are congruent. So this also will be phi. Okay, so in total I can just delete all this and write 2 phi in place of this. Now that we've established that, we can easily find the area of the sector. So the area of the sector should be equal to 1/2 r squared theta. So that's the formula for this. And 1/2, the radius for that circle will be y, so y squared, and theta in this case is going to be 2 phi. So this cancels out and leaving you with phi y squared for the area of the sector. This is quite uncomfortable because we are told to write it in terms of phi and a only, and not y. So we'll have to do something about it. But let's look at the area of the circle, the area of the bigger circle. I don't know. Actually, that is a smaller circle. But yeah, I really you get what I'm saying. So area of circle with a radius of a is going to be pi r squared. So pi r of the circle with radius of a is going to be a squared. Now the area of the shaded portion, area of shaded, is going to be equal to area of circle, which is pi a squared, minus the area of the sector, which is phi y squared. This would have been okay if we were just looking for the area of the shaded portion, but because of this condition that this should be in a and phi only, we need to do something about this y. Let's go back to the diagram and see what we can do. From triangle POR, I can see that is an isosceles triangle. So if I produce this line, the line from the center is going to bisect the line at the base. Okay, I think so. My line is not so straight though. It's going to bisect the line at the base, and also this will form a 90 degree. So bringing out triangle P, let me draw its O. Let's call this one W. So this is phi. Then this P, this are W, and this are O. So this is A, and this will be y/2 since it divides it into 2 equal halves. So I can quickly write something in terms of y, and this is 90 degrees. So we can use cosine, I think. So cosine, let me just work it over here and I'll transfer it. So cos phi in this case is going to be equal to y/2 divided by a. Okay, so let me just take this one from there, then we continue over here. So this can now continue to be cos phi is equal to y over 2 times 1 over a, so 2a. Then y is equal to 2a cos phi. If that's the case, then we can say that area of the shaded portion is going to be pi a squared minus phi. Then y is 2a cos phi. And this should simplify to pi a squared minus this is squared minus 4a squared phi cos phi. Hopefully we've done everything right. So 2 squared is 4, a squared is, and this cos squared, cos squared. We nearly messed it up. Okay, so yeah, this is quite an interesting question, and if you want, you can further simplify this or factorize a squared to get phi minus 4 phi cos squared phi. So whichever way you feel comfortable with, it's fine. Okay, so let's move on to, we've done 20 minutes already. Whoa, let's move on to question number 3. In this question again, we're told that all angles are in radians, blah blah blah. Yeah, the diagram shows a sector OAB of a circle with center O and radius 20 centimeters. So let me indicate this radius as well. The perimeter of the sector is 65, and CA and CB are both tangents to the circle as points A and B, so that the triangle ABC is isosceles. Nice, right? We're going to use that information very soon, with AC equal to CB. The angle AOB is equal to theta. Find the area of the shaded region. So I always like when questions build up this way, because of the fact that I was given the perimeter of the sector. So if you don't know what to do, at least you know you won't get 0 on this. At least you should get a mark on this one out of 9. You can't just solve this one and get everything wrong. So perimeter of a sector, we should know that there is a formula for it. Perimeter of a sector is equal to R2 plus theta. If you don't know this, it's fine. Our perimeter of a sector basically will look at the length, that is a radius plus length of arc. So if we've got radius plus length of arc, which is r theta, this will give you 2r plus r theta. Factoring out r, you get 2 plus theta. So that's, by the way, so that's the perimeter of a sector. We're told that the perimeter of sector is equal to 65. So the radius is 20, so 20 multiplying 2 plus theta is equal to 65. Then dividing both sides by 20 and subtracting 2 from the results. So 65 divided by 20, then you subtract 2 from the answer, and that will get you 1.25. So theta is equal to 1.25. Okay, so that is fine. So that is 1.25. Another angle I think we should be able to find would be this angle. The sum of the angles should be equal to 180 degrees. That is if you are working in degrees, of course. If you are working in radians, then the sum of angles should be equal to pi. That's what I mean. This is already 90 degrees, and this is 90 degrees. And this, whatever it says in degrees, it's fine. You can just convert it to degrees. It's not advisable though. It's going to waste your time. So I'm just trying to tell you that the sum of these angles would be equal to pi. So I can just solve for alpha quickly. So alpha plus 1.25. I don't even know if you're going to use it, but let's solve for it anyway. It's equal to pi. So let's do pi minus answer. That is going to be 1.892. So 1.892. Okay, so let me put it over there. 1.892. 1.892. Now, what else can we find? What are we aiming at? Area of the shaded region. So area of the shaded region, there are lots of ways to go by this one. One way I can think about would be finding the area of triangle ABC. Find the area of the triangle ABC. You find this entire triangle. Then we subtract from this the area of, let me use a different thing, the area of this, the segment, and that can get us the area of the shaded portion. Or another way to do this, I think this will be more efficient, so I'm going to use that method instead. So would be trying to divide this one into two, find the area of this side, this part of the triangle, which is going to be the same as the area of the other side of the triangle. So that's going to be the same as the side. Then you would subtract from this the area of the sector. I think that strategy will be faster than the other one. I think a common mistake would be students who assume that there is also 20. That is actually very wrong. You can't just make that wild assumption. The fact that this is 20 doesn't necessarily mean that that will be 20. So let's try to find a way to get this side sorted out. Since this line is drawn from the center, there is this theorem in circles, a tangent and a tangent. Yes, so this line will always bisect the angles over there. So I can say that this portion of the angle, this small part of the angle, should be 1.25 divided by 2, which will give you 5/8, which is 0.625. So 0.625. I'm going to use this one to find AC. This is a right angle triangle. Let me try to bring it out the way it looks. So this is 20, this is a 90 degrees over here, and there is 0.625. And I'm finding this side. Let's call the small side x. So we can use tan. So tan 0.625 is equal to opposite, which is x over 20. Then you cross multiply, this will give you 20 tan 0.625 equal to x. So let's do this quickly. 20 tan 0.625, and that should give you 14.43. So x equals to 14.43. So that's 14.43. So just like I said, it's not the same as the radius. So 14.43. Oh, that's more or less like a square. This is not a square, my bad. The opposite side, let's not confuse ourselves over here. I would have said rectangle, but the opposite sides are not parallel, so let's not go there. I can now find the area of the triangle. So area of the triangle is going to be equal to half base times height, but times 2 of half times the base, which we know the base to be 20, and the height we just calculated for as 14.43. that will give you the area of the entire figure you see. So basically 20 times this one should do the job for us. So 288.59. So 288.59 should do the job for us. So there's the area of the two triangles. Now to get the area of the shaded portion, I need to find the area of the sector, then subtract from what we just calculated for. So area of a sector, which is going to be equal to half r squared theta. So half r squared, r is 20, so 20 squared, and the theta we calculated that to be 1.25. So multiply by 1.25. So let's say 0.5 times 20 squared times 1.25. Okay, so that's 250. So that's 250. Therefore, area of the shaded portion would be 288.59 minus 250. So 288.59 minus 250, which is going to be 38.59. So that's 38.59, and that will find the area of the shaded region. It looks quite complicated, but it wasn't so complicated after all. I would rate the other question as more complex than this one. So yeah. Yeah, that's all for the circular measure question. We've done 30 minutes already, so let's end over here and do the next set of questions. I don't want my videos to be that long. I know when it's long like that, it's kind of like irritates some people. So that'll be all for today. We'll meet in part 2.